Hi, today's session is on correlation coefficient. Precisely, we'll try to calculate Karl Pearson's coefficient for such a situation which belongs to case 2. Now, recall our earlier session on correlation coefficient. We had discussed a case in which the data given for both the variables generate means, and means were in whole number, right? But in our practical or real-time situation, we might end up getting such data which does not give means in whole number, right? Now, it's not that the earlier formula or the basic formula of Karl Pearson's coefficient cannot be used in this case. But if we use that fundamental formula to solve problem from case 2, probably we need to do lot more calculation, right? And when there are lot many calculations, the chances of error increases, right? So to handle that part, we have another formula in which we don't require to calculate our mean, right? See, this is the formula for R. We know the Karl Pearson's correlation coefficient is denoted by small r. And if we find that means are not in whole number, instead of the fundamental or basic formula, we can use this formula. Fine. So let us proceed further. Let us take an example. Calculate Karl Pearson's coefficient of correlation between price and demand for the following data. We'll do a little revision here. In our last lecture, we said correlation is used in bivariate data. That means there should exist two variables. See, here is price, here is demand. So two variables, and we are interested to find out a relationship between price and demand. So we are supposed to answer three things: whether price and demand are related to each other or not. If at all they are related, what is the nature of their relationship? And finally, the degree of relationship. Fine. So we'll start solving it. Right. See, price is my first variable. I'm naming it as X. Demand is my second variable. I'm naming it as Y. Fine. Now what we require is, we require X, Y. Now what is, how to get this X, Y? Multiply each X with Y, right? So I'm multiplying X with Y. Same for the next X, X into Y, and the same thing will continue for all the pair values, right? So this is our XY. Next, we need to add a column which is X square. It is X square. Fine. Where is this is X square. So it is X square, right? Now X square means the value we need to get from X column. So 17 is x square, that means 17 square. So 17 into 17, right? Similarly, x square is 18 square. So 18 into 18. Similarly, it is for all the values, right? Now, we need to get y square. Now, y square means this is first y into y again. This is y into y again, right? Likewise, y square for all the y's. So we have our xy, we have our x square, we have our y square. Now let us get the summation for each column. So this is my sigma x, right? This is my sigma x. This is our sigma y, right? This is our sigma xy. Likewise, this is our x square and this is our y square, right? So let us try to solve the problem. This is our formula. R equals to, now see, it says in bracket n into sigma xy. N is number of observation. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. That means it is 9 into sigma xy. So what is our sigma xy? That means summation of xy. So it is 5741, right? Minus. What we have in minus sigma x, that means this summation of x. So it is 204 into say sigma y. So summation of y 267, right? Divided by this. So we need to put square root. So here it is square root of, in bracket again, n is 9 into, see, sigma x square. Sigma x square is this summation of x square. So it is 4794 minus sigma x whole square. See, this is our sigma x, right? So whole square of this, that means 204 into 204. Bracket closed. Another bracket, again square root, bracket. See, n is 9 into sigma y square. Sigma y square is here. So it is 8607 minus, this should be y square. I'm sorry. Just make a little change in our formula. This should be y square. So sigma y whole square. See, sigma y is here 267. So that is why it is 267 into 267, right? And bracket close. Finally, we need to close the last bracket as well, correct? So let us now try to calculate R. R equals to, see, I'm calculating one by one. In bracket, it is 9 into 5741. So 5741 into 9 is 51669, right? 51669 minus 204 into 267 is 54468. 54468. Let me close the bracket, right? Now divided by, I'll take this. So it is square root of 9 into 4794. So it is 43146. 43146 minus 204 into 204. So it is 4116. Sorry, 41616. Fine. Again, it is square root of, now we have to write the y part as well. So this part, this is 9 into 8607. So it is 77463. 77463 minus, lastly it is 267 into 267. So it is 71289. Close the bracket. Right? So R equals 2. Now see, 51669 minus 54468 equals to minus 2799 divided by, say, square root of 43146 minus 41616. So it is 1530 into, again, square root of 77463 minus 71289. So 6174. 6174. Fine. So R equals to, should I close this? So it is minus 799 divided by, now square root of 1530 is 39.11, right, into square root of 6174 is 7857. Sorry, 78.57, right? So R equals to, now it is minus 2779 divided by, we need to multiply these two, 39.11 into 78.57. It is 3072.87, right? So finally, R equals to minus 2779 divided by 3072.87. So it is minus 0.04, right? So what we found out is, first, just first, price and demand are related to each other. Second, price and demand are negatively related, right? See why I have written price and demand are related to each other, because the value of R is not zero, right? So that is why they are related to each other. Now, since the value of R has come with a negative sign, that is why price and demand are negatively related. Now, what is the meaning of negatively related? It means the movement of both the variables will be opposite. That means if price increases, demand will decrease. If price decreases, demand will increase, and vice versa, right? Finally, the third is degree of relationship is 0.904, right? So see, actually, since I was aware that the mean of price and mean of demand will not come in whole number, that is why I directly jumped into this formula, right? Actually, uh, we should have checked first, right, whether it is coming in whole number or not. Suppose we are supposed to do so, then I could have used this part, say mean of x equals to, now see it is 204 the summation and we have 9 values. So 204 divided by 9, it would have come 22.66. Fine. Similarly, if we calculate mean of y, it is 267 divided by 9. So it is 29.66. Now imagine a situation where you have a mean of 22.66 and 29.66. How problematic this could have been if we would have applied our fundamental formula, because what we used to do, we used to subtract 17 minus 22.66, 18 minus 22.66, right? So calculation could have been much more difficult than this. So that is why if mean appears in whole number, use the fundamental formula. If mean appears in fraction or decimal, then go for this reduced form, right? So hope you have understood the concept. For any further query, you can contact me on erg.srkr86@gmail.com, right? Thank you.